Hi class, this is Neil and this is lesson 9 on domain and range. So for Arduino here, we're actually reviewing a concept we looked at the last lesson, so let's take a look at the problem. The function f of x, h of x, and g of x are shown below. So notice, f of x we have a table, h of x we have an equation, g of x we have a graph. All right, so we're told put the functions in order from greatest to least, average rate of change, on the interval -3 is less than or equal to x, which is less than or equal to 0. Justify your ordering with calculations and an explanation. Okay, so notice the concept here is average rate of change. Remember, average rate of change we find using the slope formula. Change in y over change in x. And we need to order these from greatest to least. So this problem is going to take a little bit of time, mainly because there's a lot of calculations involved. So first let's start with f of x. All right, so we're using our average rate of change formula. And now if I turn to my table here, I see that on the interval -3 to 0, those are x values. So at -3, my y value or my f of x value is 7.8. At 0, my y value or my f of x value is at 20.5. Now I'm just going to label these x1, x2, y1, y2. All right, so plugging this into the equation, I'm going to get m equals 20.5 minus 7.8 divided by 0 take away -3. Okay, so simplifying that then, let's see how much space I have. Let's take away that 0 there. All right, equals, so I'm going to need to turn to a calculator. I don't really want to try to do this in my head. I know Carrie tried in the live class, but I'm going to change it here. So, okay, let's go to Desmos. All right, so that's 20.5 minus 13.8. We get 6.7. Oh, sorry. Minus 7.8. Okay, you got to be careful. Okay, it's 12.7. Great. So 12.7 in my numerator. 0 take away -3 is just going to be +3. So now if I divide 12.7 divided by 3, go back to Desmos. Oh, no, I don't want to do that. Okay, so 12.7 divided by 3, and I get 4.23 repeating. Okay, so my average rate of change for f of x on that interval is 4.23 repeating. All right, so next I'm going to look at the one that I think is a little bit easier to calculate, and that's the graph. And the reason I'm saying the graph is easier to calculate here is because all I really have to do is compare my rise to my run. So let's do that. All right, so g of x is my graph. I'm going from -3, there's -3 there, to 0. All right, so my rise, remember, is my vertical change. So again, we're doing the same thing, average rate of change, y2 minus y1 over x2 minus x1. But because this is a graph, I can think of that as rise over run. All right, so my change in y values, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is 10. My change in x values, or my run, is 3. Okay, so 10 divided by 3 then is going to be 3.3 repeating. Okay, so finally let's look at h of x. H of x is a little more challenging because we're just given an equation here. But ultimately our goal is the same. We're going to be finding the average rate of change. But to do that, I need to find out what are the y values or the h of x values on that interval. So what is h of negative 3? And what is h of 0? Okay, so first let's find h of negative 3 just by plugging it into that equation. So that's negative 3 squared minus 5 times negative 3 plus 3. Okay, so negative 3 squared is 9, but we have that negative on the outside, so it's negative 9, negative 5, and negative 3 gives me positive 15 plus 3. So h of negative 3 is going to be, that would be 6 plus 3 or 9. Okay, let me just... Okay, so that's h of negative 3. I'm just going to erase my work here so I don't run out of space. So h of negative 3 is 9. Now you can always use a calculator to do that. And now h of 0, all right, so h of 0, I'm going to plug in 0, but 0 makes it really easy. So 0 squared is 0, and minus 5 times 0 is 0, 2, so I'm just left with 3. Okay, again, I'm going to erase my work because I don't want to run out of space. That was 9. Okay, so now let's plug in the values into our equation. So I've got, this is my x1, y1, x2, y2. Okay, average rate of change. So it's y2 minus y1 over x2 minus x1. So for this particular example, we would have 3 minus 9 over 0 minus negative 3. So that means that my average rate of change is negative 6 over 3, or negative 2. Okay, so now we're actually not done because we need to order them from greatest to least. So from greatest to least, here are my 3 average rates of change. The greatest one is f of x, and that is greater than, well, let's do it as a sentence. So the average rate of change on the interval negative 3 to 0, ordered from greatest to least, is f of x, then g of x, then h of x. And if you wanted to add an explanation sentence, we could say because 4.23 is greater than 3.3, which is greater than negative 2. So there's our explanation. If you need to zoom in, I guess we could zoom in on that. That got a little messy. All right, that's the do now. Oh, there's another one in the do now. So reviewing interval. So an interval is graphed below, and we have this interval with an open circle showing that negative 3 is not included. And then to 1, which shows that 1 is included because it's a filled in dot. Okay, first, inequality notation. So we're interested in the interval between -3 and 1. So for inequality notation, I'm going to kind of put the x in the middle. So that -3 is not included. So we know that x is greater than -3. That's why the mouth of the inequality sign is open towards the x. And I also know it is less than or equal to 1 because that 1 is filled in. Now in interval notation, we have to kind of decide between parentheses and brackets. Parentheses means not included. Brackets means included. Okay, so in interval notation, -3 is not included. 1 is included. Okay, given by how those circles are filled in or not. Okay, so today we're looking at domain and range, right? So I don't remember if I think Carrie defined it beforehand, so I'll go ahead and do that too. So what the domain represents is all x values included within the interval. I guess you could say the defined interval or the interval. So the range represents all the y values included in an interval. Okay, so we have this function here. So that's the definition for you to write down. We have this function here. The function f of x equals -1/3 x squared plus 2x plus 4, and it's graphed for us on a specific interval. So we're asked to determine both the domain and the range and write it in inequality notation. So remember, the domain is going to be all the x values. The range is going to be all the y values. Now, if I take a look at my function, and again, this is an inequality notation. Let's talk first about the domain. If I look at my function here, I can see that it has a leftmost bound and a rightmost bound. So if I were to draw a vertical line here, is that vertical line, does that intersect our function in any place? No, it doesn't. So one thing you want to ask yourself is, what is the leftmost bound or the leftmost place that that function touches? So if I move my kind of vertical line here, I move it along the function, the leftmost bound of the function occurs right here. Okay, so that's at -3. So I know that my x is going to be no less than -3. Now, one thing to notice is that we have a circle that's not filled in there. So we're going to just use a less than sign. And now to determine our right bound part of the interval, we can do the same thing. So I'm going to draw hopefully a better vertical line. Okay, so if I move that along the function, if I move that along the function, I can see that it intersects the function, the rightmost x value is at x equals 6. Now, one other thing to notice is that this is a filled in circle here, so I'm going to include x is less than, x is less than or equal to 6. Now for the range, we're really interested in the y values here. So what is the smallest y value and what's the largest y value? So we're interested in y. All right, so for this problem, I'm going to use, for this part of the problem rather, for range, because we're talking about y values, I'm going to use horizontal lines. Now, first I want to ask myself, what's the smallest y value I see there in that function? Now, if I move my horizontal line up and down the function, I can see that the smallest y value occurs here. Okay, so that is at y -5. Now, is that y value included? It's not included, so I'm just going to do a -5 is less than y. And now, to find my largest y value, I'm going to go up and down my function. And the largest y value doesn't occur here. It occurs where the function reaches its maximum point, which is there. Okay, and that y value is at 7. Okay, so we have less that y is less than or equal to 7. Because notice it's a solid line at that point. Okay, so in interval notation then, our domain does not include -3, but includes 6. So I draw a parentheses and then a bracket. Okay, so my range here does not include -5, but it does include 7. Okay, so let's look at the second example. Okay, let g of x be the function graphed below. Determine the domain and range of the graph function in inequality notation. Okay, same thing as before. I'm going to draw a vertical line, if that helps me. And I'm going to see, for my domain, which are my x values, where's the smallest x value located at? And it's here. Okay, so for interval notation, for inequality notation, x goes in the middle. My smallest x value there is -5. And it is a filled in dot, so I'm going to have less than or equal to. For my range, for my highest x value, going along the function, I see it's here. So it's also included, because there's a filled in dot, so it is x is less than or equal to 7. Okay, so for my range then, range, remember, is y values. So I'm going to draw a horizontal line to kind of help me see it. My smallest y value here, let me just cut this out. My smallest y value occurs here, so that's at -4. And it is included because there's a filled in dot. My largest y value occurs all the way up here, and that is at 9. And notice it's a filled in dot as well. Okay, so for the domain and range and interval notation, everything is included here. There's no empty circles. So the domain extends from -5 to 7. The range extends from -4 to 9. Okay, there are a few practice problems you were asked to do in Desmos. Again, just be careful about this unfilled in circle, so that empty circle there. we could look at the first one, I guess, together. So in an inequality notation, we're interested in the domain and the range. I'm going to kind of start us off just by putting an x and a y so I don't forget. Now for the domain, which is the x values, if I need to, I can draw kind of a horizontal line. I'm sorry about that, a vertical line. And I can see that the leftmost bound is at -3. And that -3 is not included because it's an empty circle. The rightmost bound, or the rightmost part of the function, occurs here. So that is at 8. And again, it's not included. Okay, so for the range, we're looking for the highest and lowest y value. Okay, so I'm going to draw a horizontal line. Let's find our smallest y value first, which is all the way down here. So that's at -9, and that's a filled-in dot, so it's included. Our largest y value is all the way up here. Okay, so that occurs at 6, so less than or equal to 6. And again, it's a filled-in dot, so it's included. All right, so that's it for this video. The last one is in interval notation. So you want to think about, is it included here, or I'm sorry, is it not included? So that's parentheses, or is it included, which is brackets.